Greetings. I'm really glad to be here today, and I am excited to talk to you all today about service meshes, and more specifically, how we can better understand them and how they operate using widely adopted approaches in monitoring. Now, before we get started, I'd like to take a moment to introduce myself as well as Containous. So my name is Kevin Crawley, and I am a developer advocate for Containous. And I started in April of this year. And prior to that, I worked for Instana, where I was also a developer advocate. And if you're not familiar with Instana, they are a APM/monitoring company. And my traditional background is in software engineering. I've been building applications in some way, shape, or form since I was about 8 years old when I started with BASIC. And since then, I've learned a number of different languages and disciplines, as well as I've worked in full-fledged software back-end development, front-end development, as well as developer-focused tooling, which is the area where I mostly focus on today. I understand and I've used a number of different languages, including Go, Java, Python, PHP, Perl, and I've done a lot of tutorials. Never really built any production code in lower level languages like C, but I understand how they work. I've been working with distributed applications in one way or another for around 10 years. And I also do a lot in the community. I am an organizer for DevOps Days Nashville. I've done quite a bit of speaking around the world in conferences as well as meetups. And I also organize the local Docker and Go meetups. So who's Containous? You may or may not have heard of us before, but you probably heard of a very popular open source tool that we built, and that's Traefik. We also built Maesh and Jaeger, and today we're going to cover a little bit about Maesh, but I'll talk about that later. We also offer Traefik Enterprise Edition, which is a commercially supported version of Traefik. We offer SLA agreements as well as hardened security and authentication features in addition to some other stuff, but we're not going to talk about that today. Currently, Containous employs around 35 or 38 people globally. We're all over the place. I'm in Nashville, Tennessee, and we have people in San Francisco as well as France, and there's probably some other places I'm missing as well. So the topics we're going to cover today, and I'll touch on this briefly because we're going to really expand on each one of these topics as we move through the presentation today, but we're going to talk about what a service mesh is and what some of the benefits and drawbacks of the service mesh are. We're going to talk about observability, what it is, and what role does it play in cloud native architecture. And then we're going to talk about Mesh because we're going to be using Mesh in a technical demo to demonstrate how the service mesh works, as well as how observability works. So we're going to cover why we built Mesh and how it differentiates itself from something that you may commonly associate with service meshes today, like Istio. And finally, the demo. We're gonna observe the application of a canary test of both Northwest, which is ingress and egress traffic, as well as east-west, which is inter-service traffic. This is service A talks to service B type traffic internally in the same Kubernetes cluster. And we're going to use Traefik and Mesh to achieve that. So first, what is a service mesh? For those of you who may not be aware of what it is, it is, in essence, it's a new networking layer that's introduced into your cluster, and often it replaces kubeproxy and by rewriting IP tables and rerouting everything through it. Now, it does this because a lot of the features within the service mesh can be managed through YAML. Yay, I guess. But the point here is that we're not managing a bunch of policies and routing rules in our applications when they want to communicate internally or if they want to egress externally. It's also not only about traffic management, it's also about security, but we're not really going to focus on the security topics today because we only have so much time. So what are the benefits of using it? Well, the idea, and I mentioned it in the last slide, is we get a lot of abstractions. So it adds additional functionality to that service-to-service east-west communication and allows us to do some advanced routing that just isn't possible with kubeproxy. And that includes things like traffic splitting with weights. So in other words, we can send more traffic to a version of a service rather than another service without having to create a bunch of replicas to essentially hack the round-robin load balancer. Now, it also allows us to implement control policies, which would limit services being able to talk to each other and their specific endpoints. And we'll cover how that works when we talk about the service mesh interface later. It also allows us to implement mutual TLS and issue CA certificates. Again, that's diving into the security realm of things. We're not going to cover that today. And also allows us to do some advanced traffic management, things like retries, backoffs, and circuit breakers. Now, what this allows the operators of these applications to do is it lets them run the network management layer and manage it outside of the context of the applications themselves. Now, the reason you might want to do something like that is because if you're running a polyglot of services, a bunch of different frameworks, a bunch of different languages, trying to centralize and manage the configuration of that across all those different technologies, not only is it probably impossible, but it's really, really difficult. So if we can abstract it away and manage it in one place, it sort of makes sense and it's a good idea. And finally, it allows us to have a centralized emission of metrics and traces that help us identify and understand how this network layer is behaving. And we'll talk about that in the demonstration after we talk a little bit more about what observability is. So before we cover what observability is, as well as the service, as well as observability, we want to talk about the topology of Istio, because that's one of the major ones out there. They're not all like this, but this is just one that most people are familiar with. And how this works is that every single application or pod that gets deployed on your Kubernetes cluster gets a proxy, essentially. And the rules are propagated to every pod, and it's mostly an all or nothing approach because this rewrites IP tables, but this also allows us to have really granular control over the traffic coming in and out of those services. Now, I realize that every single service getting a proxy is sort of an ongoing joke. It's just like, wow, that seems excessive, but there's good reasons for it, and it allows that full control of the ingress egress traffic, but that does come at a cost, and let's cover what some of those are. What are those drawbacks? Now, adding another network hop, regardless of how you implement that, is always going to create latency and overhead. And if you're applying management policies and rules and regexes, as well as decryption and encryption, that is there's no way around avoiding that overhead. It's there and you have to account for it. Now, another point is that network traffic and policy management just isn't trivial. The security, authentication, the policies themselves, and this is most definitely doubly so if you're already doing these things somewhere else and trying to move it. Like if you already have policies in place for your applications using some other tool that's external to Kubernetes, trying to bring this internal is going to be very difficult. And another thing that sometimes gets overlooked is that if you're running mostly a common framework and application language across your application. For instance, let's say 98% of your applications are Java and Spring Boot. You're going to find better and more feature-rich support for some of these features that come in the service mesh within that framework itself, because they're usually designed specific to how those applications behave. And I'm talking about things like Feign and Hystrix and some of those types of tools. Again, if you're running a polyglot, that doesn't apply. So how can observability help us implement and manage and understand a service mesh? Where does observability come in? So first, before we can talk about observability, we should probably define it, because there's a lot of definitions out there already. So one of my favorite definitions comes from a engineering blog that came from Twitter in 2016, and I've linked it here. I'll share the slides when we're done with the presentation. But they talk about, it's a combination of things. It's monitoring, it's aggregating logs and analyzing them. It's distributed tracing and having the infrastructure in place to do distributed tracing, as well as alerting and visualization. But you can't just buy these things off the shelf and say you have observability, because ultimately they're very separate things, but they're also intertwined, and we'll talk about that here in a moment. But for the focus of the demonstration and what I'm gonna explore today, I'm gonna talk a lot about distributed tracing, but it's not observability. Distributed tracing is just another tool. And what you can get from distributed tracing is really powerful, because you can essentially aggregate the results from distributed tracing, all the timings, all the metrics, and all the logs, and achieve a lot of the same goals that metric and logging will give you as well. But Peter Bourgon wrote a blog in 2017 where he describes this in great detail, and it's a fantastic piece of work, and I highly recommend you all read it. But the idea here is that as we start collecting all these events from microservice applications, in order for us to get value from them, we have to sort of merge them and bring them together in a way in which gives us meaningful data. So by combining metrics, tracing, and logging, we get a lot of context around those events and transactions. And we also get insights that are actionable by aggregating those request scoped events, which is tracing. So we can understand where the bottlenecks are and what we might need to do to fix it, whether it be introducing an index, scaling a database, caching something, or scaling something out. There's no prescriptive, way to fix bottlenecks in microservices, but in general, distributed tracing is one of the main tools which is going to help you understand what you need to do to fix a problem when you're trying to work on your application. So the distributed tracing abstract was published in 2010 when they built Dapper, and I'm going to read it. I usually don't read from a slide, but in this case, I think it's really important to, because when we talk about service mesh and we talk about cloud native applications, we're talking about highly complex, very fast moving projects. So they stated in this report, in this research article, that modern internet services are often implemented as complex, large-scale distributed systems. These applications are constructed from collections of software modules that may be developed by different teams, perhaps in different programming languages, and could span many thousands of machines across multiple physical facilities. Tools that aid in understanding system behavior and reasoning about performance issues are invaluable in such an environment. Now, if that doesn't describe an environment which needs a service mesh, I don't know what does. What we can take away from this is that we need distributed tracing if we're going to do service mesh, period. That's my takeaway from it. I'd love to hear your feedback and love to hear what your takeaway from that is as well. So how does distributed tracing work? How does it get visualized, and how does the distributed trace get created? And the way it works is that every transaction in the system between every service, whether it's internal or external, whether it be HTTP, a messaging packet, be it through a queue or through Kafka or whatever, RPC, anything, has a custom header or metadata injected into it, which is intercepted and processed by a system of record. So essentially, within your applications themselves, there is a hook, if you will, that collects data, processes it a little bit, and then puts an ID into the metadata before it goes out and gets the transaction flows to the next responsible party or service or message bus. So it's essentially creating a chain of record as that message or that transaction flows through your application. Now, this is visualized traditionally with a Gantt chart, and that's used to show the hierarchical structure and timing of those transactions that occur once the initial trace is generated. And in this example, you can see the front-end request. It doesn't have a parent ID, but all the subsequent traces do. They have a parent ID and then they have a span ID, and those all are correlated with each other by those identifiers being collected, generated, and passed on when that transaction goes to another system. So the tracing can help us understand how both the mesh and our applications is behaving and performing. Now, inside those with the visualization, we also get a lot of metadata about the transaction, and I'll show you what that looks like in the demo. Now, before we go to the demo, I do want to talk a little bit about mesh and how it differs from the more traditional service meshes out there. And to do that, I need to explain how mesh is a simpler mesh, why we built it, and how we came about the solution. So to do that, we need to talk about what the challenges we were trying to overcome, how we were going to implement the solution, and how do we help the community adopt the service mesh. So what are some of the challenges we wanted to overcome? Now, when we set out to create the service mesh, we heard our users tell us that the implementation of the service meshes that were already out there were difficult to configure and manage. In addition to that, they'd also considered them to be very resource intensive, consuming a lot of extra CPU memory and creating extra latency. And in a lot of cases, I recognize that could be just an implementation issue, or it could just be users may not understand the implications of introducing yet another proxy to their service layer, and especially not just another proxy, but one that is responsible for a lot of concerns. Remember that these concerns have to be addressed somewhere, whether it's in your application or some other infrastructure, outside of your cluster. So no matter what, the latency is always going to be there. That overhead is always going to be there. You're just sort of moving it around. So it's something to keep in mind. We really wanted a solution that was minimally invasive, one that could be traded out with another solution without a significant amount of effort. And we wanted to offer our users quite a bit of flexibility with how they use the network. So, we identified our challenges, right? And we felt like it was a pretty big list of problems to solve. So let's talk about how we kind of unpack that and how we came up with the solution. Now, the first thing we had to do was look at the problem that the service mesh was trying to solve. In reality, we've already talked about this, though. The service mesh is just another proxy, or rather a collection of proxies. And this typically was implemented in a way where those proxies just had a lot less features than a full-fledged proxy, like something like AJ Proxy or Nginx. Or they had proxy, like in some cases, some of these service meshes had implemented proxies and then stripped out a lot of the functionality that the service mesh didn't need. So, you know, that gave us some ideas of what we wanted to build and what approaches we could actually take. So because of that, we thought we might be able to leverage Traefik to leverage, because we already built it. It just kind of made sense. And some of the reasons that we thought it might be a good idea is because it's an actively maintained project. It functions as a reverse proxy and a load balancer. It is considered secure, and it has quite a bit of features, many of which we would need to build a service mesh. And also, any development that would go into mesh for Traefik would cross-pollinate. You know, we would be able to enhance Traefik while also enhancing mesh, and vice versa. Now, on the other hand, we recognized that we couldn't just throw a bunch of Traefiks into every pod as a sidecar proxy. Traefik, while lightweight, is not ultra lightweight. It's not. It's a full featured proxy, reverse proxy and load balancer. So we had to think about a way to introduce this to the network plane in a way in which, you know, didn't just generate tons of overhead and create problems. So what this meant is that because we didn't want the Traefik gopher to literally and figuratively be run over, we thought maybe we should just fork it and adopt some of the existing functionality or middleware, if you will, that exists in Traefik for service mesh. So what we ended up doing as a solution, though, and you might notice this, is that we didn't put Traefik in every single pod as a sidecar. And because of that, we don't have that giant amount of overhead that would have been introduced by doing so. So what we did is we leveraged the existing DNS provider, kubedns, and added a new record so that services that declared themselves as being routable in the service mesh using the SMI spec, and I'll talk about that in a moment, would route through the Traefik, which is deployed, the mesh Traefik, which is deployed as a daemon set across the Kubernetes cluster. So this gave us some pretty unique advantages in that we were able to still leave kubeproxy in place so that if you wanted to, you could still connect and talk to another pod directly using the standard routing, which is, you know, cluster local or cluster namespace. I can't remember exactly what the naming semantics of it are. And I feel like that's a pretty good trade-off, because that allows you to still have that direct connection if you need that really low latency load balancing functionality. So let's kind of recap what mesh is and how it works. As you can tell, we ended up using Traefik because we'd found a way around the, you know, every pod gets a sidecar approach. And because of this and how we architected the solution, it became relatively lightweight and minimally invasive. Just remember that everything has a cost, and we are introducing another proxy to the system, albeit we're not introducing 500 proxies if you have a Kubernetes installation that has 500 pods on it. So as a result of that, the opt-in behavior became as easy as just defining a new domain name in your service routing definitions. And that made the mesh opt-in, and it becomes more transparent, in my opinion, in that you understand when traffic is going through the service mesh and when it's not. And I'll cover that in the demo as well. In addition, we implemented the SMI spec, and I'm going to cover that next so you can understand how that works and what makes it really powerful to use. So I covered most of these features during the intro, but because of Traefik, the amount of work actually required to implement all of these features was minimal. We were essentially putting a small shim in front of Traefik and committing some of the features we needed to accomplish into Traefik, and then pulling in Traefik as a library for the mesh binary. So how do we utilize Traefik using standards? Now, the service mesh interface that was created by Dice Labs. They were acquired by Microsoft. And even though they were acquired by Microsoft, as we all know, Microsoft is doing a lot of work in open source, and this is one of the projects which has continued to flourish under them. And the goal of the project was to provide an abstraction to the configuration of some common use cases in service mesh. So let's jump in and go over a few of them. So in this example, we're going to talk a little bit about access controls. And to do this, we need to define the resource. And in this case, it's our routes. And you can see some fairly common verbs and vernacular here. And it's pretty straightforward. And what it does is it enables us to create groups of these resources that we're going to use later so that we can define which services can actually access them and where those rules will apply. Now, in this example, we're applying that rule, and what we're saying here is that the API service, that the metrics endpoint can now only be accessible by services which have the Prometheus service account attached to it. And one will probably assume that only Prometheus has the Prometheus service account attached to it. So that means you've effectively limited the metrics endpoint to be accessible only by Prometheus internally. And the corollary here is that we are now assigning services that can access the API service routes. So we're saying here, in effect, that only the payment service and the website service internally can communicate with the API route. So we can also configure the HTTP route group against any number of different options rather than just routes or methods. And we can inspect things like cookies, user agents, headers. And this becomes pretty powerful because when we want to route traffic based on specific users or specific conditions, technology or metadata, we can use this to create A/B test and canary testing in effect. So let's take a look at this configuration and look at what it's doing. We're essentially targeting Android users with the user agent, and with the cookie, we are looking for users who are an insider. And these are probably users who have opted into testing for us, which is very kind of them. So speaking of canary testing, even configuring that with the service mesh is pretty straightforward. And we'll cover that in the demo coming up. And in this example, we're creating a traffic split, and which we're going to supplement the routing for the targeted service. So we're essentially just going to swap it out. The service website now routes to serve website v1 and website v2 using these weights. And so you don't have to deploy 1,000 different website V1s just to route, 0.1% traffic to website V2. You can just use this weighting system to do the routing for us. So now, what if we combine that HTTP route group to our canary traffic split? Now we've effectively created a canary in which only applies to that specific route group, and only Android users who have opted into testing is going to be effectuated by that canary traffic split. So it's demo time. Now, hopefully demo gods are in my favor, and let's get started with it. So what are we going to do today? We're going to go over a fairly complicated microservice demo in the grand scheme of things. Demos are by definition usually not very complicated, but in this case, the Spring Pet Clinic demo is fairly large scale, has several services, does inter-service communication as well as ingress, and I also introduced Kafka and a notification service because I like making things complicated. What engineer doesn't? Now, in this demo, we're going to demonstrate tracing and metrics on the following types of traffic: north-south, normal ingress traffic. This is me going to the website and clicking around. Also, we're going to do some canary testing of the ingress traffic using Traefik. Yo, dog. Now, also, we're going to do east-west canary testing of the mesh traffic and east-west standard routing alongside mesh routing. And I'm going to visualize this stuff using Grafana and Jaeger because those are open source tools. They're free, and I don't really have to pay for them. So let's get started with the demo. So just briefly on the Pet Clinic microservices, this currently is up and running, but I haven't installed the service mesh yet. And many of my services have defined the internal DNS name in which they're going to communicate with each other with as mesh. So in many cases, it's not going to work because the service mesh just hasn't been deployed, and this DNS name hasn't been defined yet and doesn't route to a service. So let's see what happens when we start clicking around in here. As we can see, we're really not getting anything because well, we can see here that we have a basic list, but as soon as services need to start communicating internally, we can easily see here why it's failing by looking at the response. And internally, it says that there is an IO error, can't communicate with this DNS. So we need to fix that. And to do that, we just need to deploy our service mesh. And to do that, we just run this Helm command in which it will deploy. And we can actually, I'm going to start a load generator just so that we have a bunch of traffic and a bunch of stuff happening within our cluster, so we can start poking around with it. All right, so within Jaeger, we can see our various services have been discovered by Jaeger. And for the purposes of this demo, we're gonna do some stuff with customer service. So let's take a look at some of these traces. We can see here for the past couple minutes, let me increase the number of results, that there wasn't really a lot of traffic. All of this stuff is mostly just health checks and administrative checks, like the admin server checking in and making sure that the application is still up and running. So these are just essentially basic health checks. As you can see here, this is failing because admin server local.mesh isn't available. But now that we've deployed mesh, we can actually see that our services are communicating with each other and that things are happening. So if I refresh this page now, we'll actually get data coming back from it once this stops pending. There it goes. All right, so it just had the load from the database, and warm up any cache. So now things should probably run a lot faster. As you can see, it's pretty snappy right now. So everything's working. We got our mesh installed, and we can even see here that our traffic is coming in to spc.kevincrawley.io. It is getting picked up by Traefik, and this is actually a CRD that's defined to strip off the prefix of API, because the request is coming in, and it is coming in at /API/owner/owners, but the service itself doesn't recognize the API on that route. It only recognizes owners/10, because owner, API/owner, is how traffic is going to route to this particular service. So how does that work? How do we define that and make our application actually function? So if we go to K9s and we open up our middlewares, we can see here that we have customer service, and what this is, it's attached to the ingress for our customer service ingress, and I'll show you that in a moment. But down here we can see that we want to strip this prefix API/customer before it gets routed to the customer service itself. So if we look at our ingress route of customer service, we can see that the path prefix is API customer, and that's how Traefik knows to route to this particular service, because we have defined here that this will route to customer service and port 80, and the middleware is defined here that says we need to strip off that prefix. So that's Ingress 101, if you will. Now let's do a canary test of the ingress itself. Now I'm using an application that I built myself to deploy these services, because deploying a bunch of microservices is actually non-trivial, and I use this script and another YAML file to define all the parameters that are needed to essentially scaffold and stand up this application. And I'm going to use that now to deploy versions 1 and 2 of the service, as well as change my this rule on the ingress route so that it will split that traffic, and we'll start seeing traffic going to versions 1 and 2. So let's go ahead and make that change now, and I'll show you what that looks like once we deploy it. So I'm going to deploy the version 1 and the version 2 of the service. As you can see here, Commander is really just doing some automation around pushing an image into my cluster, and then because I don't have these images hosted anywhere, it's using Kind, which is a integration testing tool for Docker that has become now adopted as a local development tool for Kubernetes. And then we're doing a Helm install and pretty much just filling out some values and doing some configuration. And I'm going to deploy V2 as well. Now, the next thing I need to do is update this project and turn on canary testing. And that's going to change some things in the Helm chart that was defined for these applications. And I'll show you that in K9s here in a moment. But for now, we need to redeploy the initial version of the customer service to create this canary routing in the ingress route. So again, this is just a matter of deploying that service, and it will apply that new routing rule. And again, I'm going to show you what that looks like in K9s. All right, so let's describe that now. All right, so we can see here that that changed. We have different services defined here. We have V1 and V2, and the weights are 3 and 1. So that means 75% of the traffic is going to go to version 1, while 25 is going to go to version 2. Now, how do we confirm that, right? It's one thing to show it here, but it's another to actually see it in action. So let's take a look. So now we can see here we have V1 and V2 of the service. Now, if we find traces here, it looks like a lot of the traffic here has stopped to V1. That's peculiar. I wonder why that was. Well, it's because most of the traffic is now being pushed into V1 and V2 of our service. But we can see here that the majority of the traffic is actually going to V1. So if we switch back to V1, we find traces. We can see that there's significantly more activity here on our customer service V1 rather than V2. But there's still traffic being routed to V1. And why is that? Well, let's take a look. Even though all the traffic coming into our application originates from our external service, a lot of it is being generated from service-to-service communication. And what we can see here is that customer service.local.mesh, that traffic isn't getting canaried because it's not coming in from the ingress route. So in order to direct traffic to the version 1 and version 2 service, we need to deploy a traffic split. And what does that look like? Well, it looks very similar to the one we just deployed for the ingress, but we're deploying it using the SMI spec, and we're saying, well, we want to split the traffic between these two services internally. So let's apply that. So now if we go back here and we load up the customer service, it's probably going to take a few moments for this to give us some meaningful visualization. Let's check out what all of this looks like in Grafana and how it relates. So let's take a look at the last 15 minutes. We can see the increase in traffic. And here we can actually take a look at our status. So when we deployed our canary, we can see that our errors increased, but we don't really know where. And that's where tracing comes into play, because we can use that sort of to pinpoint where those errors are happening. But we can also take a look at how our services are being routed here at the bottom. Sorry, let me increase the font here. And there's two different things going on here. One, local customer service is the route defined within the mesh, whereas the Kubernetes CRD is the one defined by traffic ingress. So we're looking at values from different providers within service providers within traffic, but this can help us understand a little bit around where those services are being routed and how they are. But it requires really intimate knowledge of how the routing works, and that's why I think tracing is just a better tool. Because, for instance, let's open this back up, and let's see. We can see here that pretty much 2 minutes ago, all traffic stopped to this particular version, because we're not routing traffic to it anymore. We're doing version 1 and version 2. And within here, we can see that most of the traffic is coming into version 1, and version 2 has a little bit of traffic, but not as much, because over the course of around 3 or 4 minutes, we've aggregated around 200 results, whereas version 1, we've aggregated quite a number more. So now, I mentioned in here that we're seeing errors happening, but where? How do we find those? If we go over to version 2 and we look for errors, oops, can't have duration. We can see here that this service is most definitely generating errors, and we can see the information about the error in the trace itself, in the span. So that is how we might do a canary test, and how we might analyze the results from it. So in this case, because we are seeing additional errors here, but we're not seeing errors in version 1, like we can't find anything with errors, we know that version 2 is bad, and we should probably reverse those routes. Now, in addition to that, we can also see here that a lot of our many of our routes, some of them communicate directly with the other service through kubed and through kube proxy, because of there is no mesh domain on here, but this one communicates with the mesh. And so that's just a visualization of how these two technologies are working together. And to me, that just is really powerful. So I'm going to leave these URLs up. You're welcome to come in here and poke around for probably the rest of the day until I shut it down. And you're welcome to ask questions about this and ping me on Twitter later if you have any questions as you're poking around. I'm also going to share the URLs in the Git repos for Commander and this version of Spring Pet Clinic Kubernetes. Even though I don't explicitly have instructions on how to set those up yet, I'll eventually get to those. So the point here is that building and delivering microservices without adequate monitoring is hard. Twitter said that, I think. But remember the Venn diagram. If you go about trying to build these types of systems without visibility, the result is going to be a lot of frustrated developers, the operators of the cluster, and ultimately your customers. Jaeger itself is great for initially getting a good understanding of how tracing works and the visualization of it. But it's definitely not free, as in scaling it and storing data for it costs money. It's not insignificant. And the user story behind extracting those outliers and those errors and alerting on them is completely proprietary. Uber has built it, but it's all internally. And Yuri, the creator of Jaeger, talks about that too. You just have to look him up on YouTube. One thing you might want to check out is Crawley, which is a Red Hat project, which does some of that. But I think it requires a very opinionated setup for it to work. So what I'm getting at here is observability isn't free. It doesn't exist, even if it's open source. The cost of building the solution to the point where the tools will be widely adopted by your organization and your team members, it's pretty high. And that's probably why I can think of 10 vendors off the top of my head who will sell you observability. Which leads me to my next point. No one is going to sell you observability. There are tools out there like Datadog, Dynatrace, Instana, Honeycomb, SignalFx, Lightstep, Elastic. They all collect data, they aggregate it, They'll deliver it to you in a way in which is can be consumed rather easily, a lot easier than some of the open source tools out there, and in a way in which is going to be easier for you to gain that value without your team trying to stitch together a bunch of these different tools and managing all the plumbing and the scaling of it yourself. I think to summarize that, it's really up to you and your team to learn how to utilize those tools in a way in which help you understand how the application you're building functions, where those problems and bottlenecks are, and if the changes that you're making are actually better or worse for your customers. So back on the Mesh, what's the future for it? Mesh, we want to keep it simple. We traded off some features to keep it lightweight, but at the same time, we want to support emerging standards that are being developed by the SMI community, which we're a part of, and we've actually donated the UDP part of routing specifications to the SMI spec. Now, further enhancements are planned, including additional SMI specs. We need to keep up to date with the implementations that they're introducing, it seems like daily, as well as introduce MTLS encryption. So what are the next steps? We'd love for you to sign up for our monthly newsletter. You get a chance to win a $50 gift card. You can do that after the presentation. We're going to keep that up for a few hours. And I'll share the URL in the chat room so that y'all can see that. And we'd love for you to get involved with our community. We have a discussion forum. We need contributors for Mesh. We need help implementing those service specs that are constantly being enhanced and new features are being added to it. And also, if you've written a blog post, you've done a video or any kind of tutorial on Traefik or Mesh, apply for our ambassador program. It's out there, and we love hearing your feedback. So it's really important to us. All right. And with that, I will open up the floor for questions, and I appreciate y'all's time and attention.
Cool. Thanks, Kevin. That's a great presentation.
Appreciate y'all sticking around and learning a little bit more about service mesh and how to observe them. I'm open to questions right now. You're welcome to ask them here or ask them on Twitter or wherever you like.
Cool, thanks. Guess we could just hang around a little bit. I'm fine with hanging around. See if there's any questions that rolls in.
Yeah, I suspect maybe quite a few people are maybe signing up for the giveaway right now. We're gonna keep that up for a little bit longer, so don't feel like you need to submit it right this minute. Feel free to ask your questions while we're here, and we'll be happy to answer those.
Yeah, we should have kind of let that link out in the beginning and did a live raffle.
All right. Well, if there aren't any questions, there's, like I said, I'm going to stand up that demo again so that people can click around on that. I'm doing that right now. It's going to take a few minutes. And right, if you can think of any questions or anything off of the presentation you saw or want to learn more, like I said, feel free to reach out to me on Twitter or through email. It looks like we have a question. Bala Sundaram asked if Maesh uses IPVS to keep track of routes. I I do not believe that it does. I believe that it uses the internal configuration within Traefik to manage that. As such, Traefik doesn't actually modify any of the tables itself. It just creates uh, a new domain record, and that's how it picks up the routes. I do want to get a better answer to your question though, and Bala, if you reach out to me, if you send me your email, you can DM me here. I'll get you a better answer of how that's implemented because I I didn't even work for Containous when it was built. So, but my understanding is it does not. But I don't have the specific answer as to how it keeps track of routes. But I do not believe it uses IPVS. Thanks, Paula. Yeah, I'll follow up on that for you. We'll hang around for a few more minutes. If any of you have questions, feel free to ask. I'm in the process of actually standing up the demo application right now, so if y'all want to play around with that, you're more than welcome to. Now, if y'all were wondering what tool I was using to visualize or show some of the configuration of Kubernetes, it's actually K9s, K, the number 9S. They recently did a new release, I think, and I saw a tweet about it. And before that, I'd been using Lens, which was a Containous product, which I believe they got acquired by Mirantis, and then they closed the project, and now they reopen sourced it. But that's another really cool tool. It's called Containous Lens, which is a GUI-based application that lets you kind of crawl around, and it's a pretty good replacement for the basic Kubernetes dashboard that comes with the project. So
yeah, that's pretty cool. How do you look at the nodes? Do you...
For in Containous Lens?
No, in K9S.
Okay, well, hold on, let me share my screen. So it has a Vim-like interface. So
yep.
Let me see if I can.
What is the nodes? How do you get to the nodes?
So let me see here. K9s. So you just what I did there is I typed semicolon and then node. And that is autocomplete as well, so you can kind of take a look at the various
Yeah, that's kind of cool.
Systems, and it does support all the CRDs, but you just have to know what they're named. So I made that mistake during the demo too, which is not auto-completing. So you know, you can pretty quickly kind of look up and see what's going on in your cluster. And I don't know, I'm partial to CLI tools because I'm just a little more efficient than trying to click around in a GUI. So I kind of lean towards those anyways. But the tool's pretty, to me, it's pretty nice. I enjoy using it.
Yeah, that's pretty cool. I like it. Yeah, I was using some like year or two ago, and I kind of stopped because I guess that's when people started building these tools. It wasn't like very feature complete, but now it looks like it's there.
Yeah, I haven't really found anything in there in which I couldn't do other than, I mean, if I want to apply a new YAML or do a Helm deployment, obviously that's K9s probably isn't the tool to do that, but everything else seems to work pretty well.
Yeah, it even gets your Helm releases and stuff too. Nice.
Yep.
Yeah.
Now, one of the things that I like about Lens that K9 doesn't do, and I'll show you that real quick, and it's probably the only reason, honestly, I still have Lens installed. Let me switch my share here. So I didn't mention it at the beginning of the presentation because it's not really.
We'll still see your K9S.
Yeah. Let me see here. Lens is that I am a
I'm in the Lens now.
I'm a co-owner for and founder of Single Music, which is a startup here based in Nashville, and I did all their DevOps infrastructure tooling and everything, and I manage. I'm pretty much their token SRE on the weekend. But one of the cool things about Lens, though, is that it does let you kind of visualize, you know, the metrics behind it, and it also lets you do things around. It lets you see, for instance, I've got a bunch of different applications deployed here, and I can side by side see that, you know, one application, for instance, you know, Shopify, it's behind staging right now. Like in production, it's 57, but in staging, it's 58. So we got some version drift there. So it helps, like having that side by side in Lens is like really nice. But that's pretty much it, right?
That's pretty cool. Yeah. Hey, wanted to see if you're interested. I was thinking about putting up a meetup together with a few folks about like Kubernetes tooling like this. Like, you know, what tools do you use? And kind of show it off a little bit. Just like what you exactly just did, kind of like right here. Be like, here's, you know, K9, this is why I like it. But then there's this other tool, Lens, which I also use in combination with that. Would you like to be part of that?
Yeah, absolutely. And you know, we use we also use Datadog at Single Music, and we've got all of our applications are instrumented to the teeth. We get a ton of really good data. I mean, in general, Single Music processes internally millions of transactions every day, and that just creates really pretty dashboards in Datadog, right? When you have a super active application running and it's really well instrumented. So those tools literally, I think, you know, in combination with stuff like Lens, K9s, as well as Datadog, is the reason why I really don't have to do much as the SRE at Single Music, because the three developers that are working there understand how to use these tools and they can solve the problems themselves, and they don't really need to talk to me that much, other than, you know, when something really weird happens. And luckily Kubernetes is really mature now and nothing really weird happens now. So that's been a benefit and saves me a ton of time.
Totally. Yeah. I remember when Kubernetes was like at 0.03 or whatever it was, and it was pretty shitty. But nowadays it's rock solid. It's rock solid.
It's pretty solid. Well, especially if you're using, you know, the cloud providers, like using their managed services. I don't think I would really ever consider running Kubernetes on-prem, just because I'm not a sadist. But like, I would probably use Nomad if I had to do some on-prem stuff. But anyways, we're going really off topic. So
I think if my company was a VMware company using VMware and their new Kubernetes adapters and stuff like that makes it a whole lot more palatable, where it's more in tune of like GKE typeness. right? You're not managing the stuff.
Right.
I wouldn't want to build Kubernetes cluster nowadays either.
Yeah, well, like I said, I mean, even here you can see that this is clearly running on Amazon, right? And and there's no management nodes. It's all workers. So that's the best part about it. Like I don't have to worry about the management plane. It just
Right.
works.
Right. Yeah, same thing with VMware's new Kubernetes. It's GKE, EKS, AKS like, right?
Right. And you know, I used to actually Single Music actually was started up in my garage on a Dell R815 with like, I don't know, it had like 64 cores in it. And 256 gigs of RAM, and I just ran like I ran Docker Swarm at the time on it, but it was just on a bunch of different VMs. And then I don't know, I think I was out of the country speaking in Spain or something when we lost power. And I had to call my wife at like 2 o'clock in the morning her time for her to get my server back online. And I was like, I told the other guys at Single Music, I was like, we're moving this to the cloud. I'm sorry. No more free hosting.
Yeah. Okay, cool.
But yeah, I'd be super interested in a meetup kind of just showing off, you know, like the tooling behind actually managing and running a Kubernetes, an application running on Kubernetes. Because I mean, even Commander, that tool that I briefly mentioned during the demo, like that came out of my work to move Single Music to Kubernetes because it was running on Docker Swarm up until about 2.5 months ago. But like I'd been laid off from Instana because of the whole COVID thing, and I took a month off of work, and I was like, all right, well, I'm going to migrate Single Music to Kubernetes. And I needed a way really to manage the Helm temp. I needed a tool to manage the tool that manages the Helm templates. And at the time, I didn't know about Scaffold. I probably would have used that instead, but I ended up just writing something myself because it was easier to address the specific use, like the specific cases for Single Music.
What would you use? How about like Customize?
Customize would probably work too. But the idea was like what I wanted to do was have a single Helm chart for all my applications, because all the applications for Single Music are JVM based and they're Spring Boot, and they're all very similar in the ways that they're configured and spun up. So it didn't make sense to have a Helm chart or a values file for every single one of those applications. But I needed some way to feed in. I needed some way to pretty much quickly bootstrap all of those different Helm charts, plus the back-end stuff like RabbitMQ, Redis, Kafka, and all the other tools that they use internally, in pretty much one command. And in a way, what I ended up building was a tool that just goes through a manifest file with some slight variations on what the values need to be pushed into Helm are, and just does that work for me. And that way the developers can spin up a full stack locally to develop, you know, within a matter of like 5 minutes. So
interesting. I've lately been using Flux or Argo, and so that solves exactly the problem you're stating. Like if you want it, like Nginx, Ingress, Rabbit, Redis, and some generic Helm charts that fires up APIs, containers, or whatever. You basically just push it on a Git as a GitOps workflow, and the developers. So me as the DevOps guy, I set up the structure and stuff like that, and be like, just plug your container in here, and what port do you want to open? Where's the health check endpoint? Plug it in these little these maybe 10-line values files, right? And they can do it all in Git, and they don't even need. There's no Jenkins, no pipelining involved. You basically merge into Git, and it ships it out there.
And that pretty much just does it for, the Kubernetes clusters that you have running in the cloud. What about their local? Do they do any kind of local development, or is it just like if you want to push a change, you just need to push it up into Git so it can be
Yeah.
deployed?
So they're using kind locally
Hmm.
for testing, so that
Right.
can fire up the same stuff as in the cloud as in local and deliver the same stuff.
Okay, I see. Yeah.
Yeah. So they.
The other thing that Commander does is it will take those same Helm templates and those same configurations and configure against the local cluster as well. So we
Mhm.
ended up using Commander for local and for in our job runners in GitLab. So
Mhm.
it's the same tooling doing the same thing. It's just it's configured against a different cluster.
Gotcha. Cool. Yeah.
But I think I had like 3 weeks to get this done. So it was like, all right, I was aware of those tools like Argo, but I
Mhm.
was just like, I don't have like
Gotcha.
infinite
Gotcha.
amounts of time to get this done. But
Yeah.
yeah, that does
Yeah.
sound interesting. And eventually, I mean, I think they're going to get to the point where uh, they'll have to hire somebody to move it to that next point because if I mean, at this point, we're in well over 2,000 stores in Shopify, and I mean,
Mhm.
like we're doing a lot of business right now. So, um, I mean, as the business grows and they add more and more developers and teams and products and services, uh, that single cluster that's pretty simple is going to become messy, and they're going to need better workflows. So,
Mhm.
yeah.
Yeah. Yeah. Yeah. And I usually tend to work. Yeah. So I have a few problems. Like I'm a consultant. I tend to work with medium to large size businesses, and like tooling is tough because usually they won't go with some open source thing that is early on and um, that doesn't have many maintainers, right?
Right.
Because yeah, because if those if that project kind of goes away, then they're like, what are we going to maintain this thing? We don't want to maintain this thing, right? So it becomes very hard to use some kind of, I don't know, like a third party tool that is not widely used or maintained or backed by a VC backed company.
Yeah, but on the other hand, if it gets the job done and it saves you money on the front end, well, that's an argument in and of itself, right? Because it's like, all right, well, by using this tool, we made the business decision to save um, all this work that we would otherwise have to do or try to find somebody to do at the calculated risk that it the project doesn't deviate too far from what we need, or the maintainers stop, investing their time into it. And at that point, I mean, you're back at the original root problem is, what do we spend money on, and how do we get the goal accomplished, right? So
Yeah.
it's like, yeah, I mean, I've heard that argument before, even in full time larger like organiz. I worked for a bank before. I've heard it all, right? But at the end of the day, it's like, all right, well, that's your arguments are valid, but we still don't have a solution, and no matter what, we're going to spend time and money either on the front end or the back end. I mean,
But Flex is the solution, right? It does everything that you
right,
said it does and
right.
more, right? And it's also backed by a VC backed company. And then it also gets you into creating these clusters, right? Like uh, Flex and Argo can create clusters now with the Kubernetes cluster API. So it's like clusters of, management of clusters, right? That's their next problem is how do you manage all these clusters sprawling around? And then, but I mean, I think these companies' time horizon is not 6 months, right? Like it's like they're averaging out the costs over 18 plus months. So I don't know. I think the bet for a smaller project is a little harder to make than to make a bet on a larger project.
Yeah, and that makes sense.
But you're right. It's all a calculation. It's all a cost calculation, right?
Yep.
Okay, cool. Great. I got to get out of here. So thanks. I'll let you know about that other tools meetup and maybe get some definition around it.
Yeah, I'd be super happy to participate in that. And
Excellent.
again, thanks for putting this together and inviting us. And yeah, I enjoyed presenting to the group.
Cool. Thanks, Kevin. Have a good day.
All right. Thanks. Bye-bye.